it and in this new tutorial. And today, hello guys, and welcome in this new tutorial. And today we are going to start Codesys. Codesys is the platform you will be using to learn PLC programming in multiple languages. Now let's dig into it and start the software. Okay, so right now we need to create a new project. You have two ways. Either you click on this one here, or you can go click on File, click on New Project, and choose a standard project. Let's call it Project 1. Click OK. And here it is loading. Now we need to choose a device. We will choose Codesys Control Win version 3.64. Since we don't have a real PLC next to us or a hardware PLC, we will be choosing a soft PLC which will be created inside our computer. Now we will choose the programming language of this PLC. There is 6 languages you can use to program a PLC in the Codesys platform, which is all the languages you could ever think of that supports PLC programming. Now we will start with ladder logic. Click on LD ladder logic diagram. Click OK. This PLC program here is your page. So if you double click it, you will see your programming page, which is right here. If you didn't see this one, you can create it by yourself. If you go to Application, right-click, and add an object, and choose a POU. Give it a name. Let's leave it like that. Make sure its type is program, and make sure you've chosen ladder logic diagram. Click on Add, and here's the page. Right now we don't need this one because we already have a page. We are going to create a very simple motor control circuit in this program. We can simply do that by clicking one time on this line right here. Once we do that, we have activated the component tab. Now we are going to use 2 components from here. This one, which is a contact, which is an NO contact, and this one, which is a coil. We'll click first on Insert Contact, and it will show up right here. Now we will click on this small rectangle and go and click on Coil. So here is our simple circuit. We have one contact which will act like a push button or a rotary switch. Once we press it, it will conduct power from this line. Let's assume that this line is 24 volt DC to our coil right here. Now, before we do that, we need to give names to this contact and this coil. So let's call this Start PB, standing for push button. We cannot use spaces here, so let's call it Start PB, no spaces. Click OK and click OK. Let's go to the coil and call it Motor 1, or just Motor. And we'll click on OK. Now if you notice in this window, we see the names we gave to our components showing up right here. So once you give a name to your component, the software will create a variable automatically. So a variable is the name of your component and the type. So in our case, the type of these components is bool, or standing for boolean. What does boolean mean? It's just a digital, either a 0 or a 1. So our start push button is a bool, our motor is a bool, since they are both a digital signals. Now let's go to simulation. If we click on online, there is this simulation right here. Click simulation, And now we are in the simulation mode. Click on Login. Click Yes. And we are inside the PLC right now. So think about this as the following. Let's say you have a real push button right here, and it's connected to your PLC. Now, once you press it, this contact right here will close. Once you release that push button, this one will open. If you have a rotary switch, it's the same. If you latch the rotary switch, this one will also latch. If you release it, this one will open. Now, this coil right here will be connected from your PLC output, let's say, to your buffer relay. So, once you give signal from here, it will go to this coil, which in turn will activate the PLC output, which will make the relay, the real hardware relay, latches. Let's see this in simulation. Say I press the push button, double click right here to see if this go to true, and press Ctrl and F7. Now this contact is closed because I have pressed my push button, or I have simulated that I have pressed my push button. And what we see is this coil got latched. And if we have a real PLC, the output will latch the real relay as we mentioned. Now let's turn off the rotary switch. How do we do that, or how do we simulate that? We double click here and we see that it is false. It means we are going to turn it off. Press Ctrl and F7 and it's off. And as we can see, the coil turned off too. Now let's put other components. Let's log out right here. And let us introduce the normally closed contact. Now click here on the middle of this line. Go to the component tab and press Insert Negated Contact, which is the NC one. Here we have it. Let's call this a stop push button. Stop push button. Click OK. Click OK. We have created the variable automatically right here. Now let's simulate this. Click on Login. Say login with download to make sure everything is okay. Click on Start and we are inside. Now let's turn on this Start push button, double click on it. We make sure it's true. Press Ctrl and F7 and the coil is latching. Now let's try to stop it. Assume that we have connected one start push button and one stop push button to our PLC inputs, and here we have our relay connected at the output. Now let's press the stop push button, double click, make sure it's true, and Ctrl F7. As you can see, the motor right now is not operating because we have cut the path going to the motor. Even though the start button is still latching, but since this one is in series, it cut the route to the motor. This is why stop buttons need to be normally closed type, so that it can cut the path to whatever it's trying to actuate. Now let us release the stop button, double click on it, press false. Now let's unlatch the start push button, double click on it, Ctrl F7, and we have got the path to our motor. Now let me restate this if it's not too clear. How does the PLC know that this push button is on or off? It's really simple here. You have this 24-volt power supply and you have connected one side of it to your rotary switch right here. And the other side is to your PLC input. So it's very simple. When your rotary switch is conducting, It's going to convey power from your power supply of the 24 volt to your input. So your PLC will read 24 volt and it will know that this signal is on, and you can link it to whatever variable you assign it to in your program. Inside the PLC, it will produce 24 volt when the program tells it to do that. So in our case, on that motor coil, when we give it power, it will be on, and this PLC will generate 24 volt from its output, will go to the relay coil, the relay will latch, and it will latch the contactor, which will turn on the motor. It's a really simple procedure. I just wanted to make sure that we're on the same page regarding this.